my screen just fine.
I can see it.
Is it in presentation mode? There we go. Let me just reorder things so I can actually see our meeting as well as my presentation. All right. Actually, you guys can see my notes, can't you? Or can you actually see
the presenter view?
Presenter view. Okay. How about now? Well, no. It's
there you go.
Oh, did that switch it? Okay. Perfect. All right. My name is Anthony Gillis, as Corey mentioned, and I work as a biological scientist for the Florida Landscape Conservation Project. And I'll be giving you guys a quick rundown and update on how we're currently using oysters as a marine indicator within our project, but I'll also be providing kind of a broader context as what our project is about. And of course, I'll start with that. First and foremost, what is landscape conservation? And it is an approach to conservation that essentially takes a step back and we look at things at a system level in the hopes to kind of integrate and reweave what's kind of been seen as fragmented landscapes that consider ecological, cultural processes and economic benefits that they can provide. And what that really entails is, of course, is a few different shifts in one, our geographic scale. So that's taken a step back and rather than going by the site-specific approach to conservation or a parcel by parcel approach and looking at the broader context of those systems. So just to provide an example, we were previously known as the Peninsular Florida Landscape Conservation Cooperative. And of course, I'd only looked at the peninsula of Florida, but since things have shifted, we're now looking at the entire state. But what also comes with that, and it was in our previous name of a cooperative, is a change in our process, where instead of a top-down point person approach, it's a horizontal approach where we're integrating different collaborators and researchers. So it's looking for that diverse participation by stakeholders, as well as a change in perspective. And that's, again, considering all lands, not just those that are protected or public lands, but also looking at private lands and those that are developed to those that are completely wild as well. And integrated manner when planning these conservation actions. Now, why do we want to do that? Again, it's this idea of collective and horizontal impact and approach to things, which allows for these four things of consistency, accessibility, and transparency, and holding each other accountable to the mission statements sent out by these landscape projects as well as collaborators. But again, and also importantly, is it provides a regional effort as well that you can then subdivide and hold partners in certain regions to that same mission. So it really just meshes all of that back together. So that's the general overview of our approach, why we want to do this. And of course, when it comes to the regional efforts, one of the things that is very important is knowing exactly where everything is. Right? Where are our resources? And so this is our terrestrial side, where we have our cooperative land cover map, which some of you may be familiar with. It essentially delineates roughly around 230 different habitat classifications for the entire state of Florida. And so these are our broad resource, but when it comes to this project, one of the things that we need to know is what are those that are most important to managers, stakeholders, researchers, and we refer to those as our conservation assets. So for our marine side of assets and indicators, we have 5 different assets that we're looking at. It's mangrove swamp, salt marsh, which come from this CLC, so this cooperative land cover map, as well as our seagrass, coral, and hard bottom. Now, one thing that isn't an asset on its own, but I am talking about today, is our oysters. It's integrated into what we're calling a system-wide asset. So that's just a broad, very broad marine ecosystem, marine Florida ecosystem asset. And again, that's where our oysters are situated as of right now. And so again, why I bring up this map is this is where we actually pull our mangrove swamp and saltwater marsh extent and spatial distribution from. And then we have the marine benthic cover map, where we pull things like seagrass and hard bottom from. And this is also a accumulation of various different data sets. So we have the unified reef map in here. We have NOAA's coral deep coral suitability modeling that have went into making this. We also have artificial reefs within this. Now, one thing that may seem a little counterintuitive is that our oysters are actually located in the CLC map, and that's just because those were put in there before I started on this marine benthic cover map. We may make that switch to put them in here where it's more suitable and where it's all in one place for people who want marine assets and marine data, but we just haven't done that as of yet. So one thing to point out too is that goes to the idea of scale is we have, you'll notice in this map, we have the state name of our habitat classifications. That's also further refined by a site name. So both our CLC and MBC are divided into those, and that's really based on the scale of the project using this data. So you do have those 2 scales of refined or broader detail. So again, we have those prioritized assets and conservation assets that that are considered most important. So what we have now is our indicators, and this is really what is the measurable expression of desired asset conditions. It serves as a mean of measuring conservation objectives and objective achievements, as well as provides ecosystem status, condition, or health. So those are our indicators, and the way they were selected was through of course, a series of workshops held in 2017 where participants, as you can see with the coastal uplands example, is just marked next to the indicator they felt would provide the best understanding of the status or health and condition of that asset. So once we had those meetings, we took our lists, brought them back. We kept everything, not just those that were received highest priority, and we did a data search just to make sure we could actually follow up and follow through with those most prioritized ones. So one of the first things we did is look for established indicators already in use. So that's, of course, things in the integrated mapping and monitoring programs, or the IMPs, and just utilizing those. So we do use those, or quite a few of those indicators in our project as is. Now, if those indicators weren't previously established, we looked for just raw data that we could then work our way through and apply to our assets as indicators. And one of the important things is that the continued collection of data, as well as their spatially widespread for sampling throughout the system. So as an example, for coastal uplands, beach mouse received quite a few, beach mouse habitat received quite a few votes, but that's a very, I know as an example, is a very concentrated area, and it's not really throughout the entire state. So that one ultimately wasn't selected for that asset. And of course, our indicators need to represent important attributes of conservation. They can respond to environmental variation, as well as allow for evaluation of conservation managements and actions, and really support those actions. And as I said, if we didn't find data for certain indicators that were prioritized above others, we did just work our way down the list to those that were further down. So here's a final list of all of our indicators as they stand for each asset. I won't go into detail of all of these, but of course, of most importance for this meeting is the one that was selected in our system-wide was oyster size frequency and oyster density. And generally, this took a spatial analysis approach where we created buffers around our assets and this intersected data with those buffers to really understand what's going on around those assets, and then looked at the averages and just looked at general trends. But the thing was with our oysters, we didn't necessarily take that approach. And I'll get into that more here in a second. But then what we did after those and after getting those trends is we took a percent change per year approach, which led to this classification of change. So if it was a decrease of 1% or more, it was considered decreasing. A loss of 1 to 0, stable but negative, 0 stable, no change, and of course the opposite for those that were increasing in those values and those annual trends. One important thing to point out is the lack of data for multiple years of concern. So to say that was there was data taken in 2018, but nothing before that. We still want to highlight where data has occurred, even if it was just for 1 year. Just so we know that these areas aren't excluded, but we just can't apply this to them. And then of course we applied some summary, applied them to summary layers for our maps. And then this is just a quick example. I'm not going to go into much detail, but of our results and how we'll be presenting them. We have a graph for trends. We have the table that shows those values as well as the percent change per year down at the bottom and the classification they received. And then we go into the spatial results and to provide, and highlight areas and regions that may need a little bit more of a focus with that same classification system on percent change per year. So as I mentioned, oysters were in a league of their own and really kind of are an asset of their own and really needed to be handled very differently. And the reason for that was just because of the projects are so spatially focused and very disparate that we didn't feel we could pull things up to a more regional level. But oysters were so important enough that we wanted to include them. So essentially we provided individual project results. So here we have Oyster Sentinel based out of Sanibel and Caloosahatchee, and you'll notice our data goes to 2016. So whether that project is continuing or not, this was kind of one exception to our indicator rule, again, because we felt oysters were so important. We wanted to present the data that was available. So you can see here's our size class frequency, which is just a count by size classes, and it might be difficult to see. But we have SPAT, which we classified as less than 25 millimeters, and then it was 10 millimeter increments up to 75 millimeters, which greater than 75 millimeters we considered mature oysters. And of course, by color is by year, and then we provide a map as to where their sampling is occurring throughout their site. And then we went on to oyster density, and of course, here's GTM NERS oyster data, and this brings back that percent per change trend idea and classification. But again, this is only applied to what's seen at this project across all of their sampling sites. So again, we don't provide that regional summarization, but want to just provide the project level. And in our technical report, we do provide just a very broad general overview of what's happened with oysters in certain regions and where certain regions do line up and what that data says. And again, this has to do with the spatial concentration of things, but also there seemed to be some differences in methodology that we didn't want to mishmash things together and have things get too confusing. So as a whole, these are the data sets we used for this project. But of course, of most important to this meeting is our Oyster data sets and Oyster projects used, which I know there are some that are probably missing. There have been a few that have been brought up to me afterwards. And that's really kind of the greatest thing about this project is we're not just limiting it to this one-time, be all or just one snapshot. In a landscape conservation, things change, so does this project. So with the future of it, we will continue to monitor as research and restoration efforts and conservation efforts around oysters continue to grow, which we all know is that's a very important thing right now. So we will continue to build out those data sets as well as refine our approaches to things. Also, as we continue to solidify methodologies, both in monitoring and mapping, the hope is to then exclude oyster extent as a potential indicator. And of course, as the indicators grow, I know we'll feel more comfortable with having oysters essentially become their own asset. So pull them out of the system wide and make them their own asset, as they probably should be with how important and widespread they are throughout all of Florida. But more it's coming up more recently is we'll be reporting all of this into a report card, an executive summary that is going to change the classification of our trends. For those that are declining will become a poor classification. Anything that's stable will be fair. A beneficial trend or an increasing trend will be considered good. And so that is, again, just a summary level. And then we also provide that with our technical report that dives into individual indicators and the specific analyses that went in to refining those data that affect those assets. And that's it for me. Do you guys have any questions at all? I will say, if people are thinking of questions, I know with the data sets and even a few of the analyses, if there are other ideas that people have, I'm very open to them. As I said, this will be an evolving and really just an evolving and adapting project. I have a few months built out before I revisit our indicators. I have a few other projects that I'll be focusing on. So if you guys would like to send any comments, questions my way later, please take down my email address and gladly discuss any of this with you guys.
Hey, Tony, this is Corey. I have a question.
Yeah.
In the example of the Sanibel data that you showed, is the size frequency, is that averaged over all sites?
It is. Yeah. Yeah.
Okay. That's an interesting one because based on river discharges fluctuating year to year, the sites can vary quite a bit year to year. At least in that particular one, because the Caloosahatchee is a highly regulated river.
Right. That's a great point. And so with this, it was again kind of just a broader look at things. But I do like that point. Let me find the right notepad. We'll write that down. There we go.
And that may or may not happen with all places. Obviously, the Appalachia system is variable, but generally in a downward trend. So that'd be something to consider if you're doing Panhandle area. So yeah, just a consideration. I know this is sort of a higher level look at things and not getting that far into the weeds. Right. I imagine each organization collecting the information, the NERS, SCCF is doing that analysis. Whether or not that's available or relevant to this, I'm not sure, but just putting it out there.
Yeah, no, that's great to know. And again, with this project, this is our first attempt at it. So we'll, as we go, we will refine these approaches and add the things that we know are going to best serve data sets.
Thanks. Let's see, we've got a couple other questions. I'll go to Sandra first.
Yeah, that was an interesting presentation, Tony. Thank you. So I'm working in Apalachicola Bay, as are a number of other people, and all sorts of data is being collected. So I was going to ask what Corey asked, but and you've already answered that one. But my other question is, are you addressing intertidal or just subtidal? And if you've already said this, I apologize. I had to hop off for a second.
Oh, no, that's fine. We didn't make a distinction between subtitle or intertidal. That is another thing that I was kind of brought up after I had gone through this analysis. But and of course, being more involved with this group now, they are very different, and I wholly intend to include that with our future versions, because they are very different.
Yeah, they seem to behave differently from the subtidal populations. And just another comment, which I'm sure it's kind of redundant, but if you want this kind of data collecting from the groups, then I'm willing to collect. We'll be out there working, and FWC will be as well. So if you let us know what would feed best into your data set, then it's all useful information. And if it can be used, then we're happy to collect it when we're doing sort of destructive sampling.
Absolutely. No, I definitely appreciate that.
Nikki, did you have a question?
Yeah, thanks. I was just curious if you had considered looking at harvest data and looking at maybe change in catch per unit effort over time or something like that for each region.
That is a great question, and I know the WIMP report had gone into that, and when I don't think it was part of any of our original indicators selected at those original meetings, so it wasn't on my list, and it didn't come in the process. So that is definitely
well, and I guess it's not a perfect indicator of habitat condition, but it is the most consistently collected data set that we have statewide, I think. So.
Right. No, I completely agree. And I think when I read the WIMP report, I was like, yeah, it's great data. It's widely, wide spatial distribution of where it's taken. Temporally, it's pretty expansive. So yeah, that's a very good point. And then I see Melody also wrote a question. I'm more than happy to share this PowerPoint with anyone. I guess, Katie, if I could send that to you or Corey, whoever, and we can get this sent out to everyone. Or if anyone wants it directly, just feel free to, again, take down my email address and send me an email.
Yeah, we can, Tony, if you send it to one of us, we can get it uploaded to the box folder.
Oh, yeah, absolutely.
Yeah, Tony, that'd be great. We are recording this presentation, and I'll post that on the box folder. If you send me a PDF copy of your presentation, I'll put that up as soon as I can.
Perfect. Cool. All right. If there's no other questions, I'm going to go ahead and stop sharing my screen.
I have one question for you, Tony. This is just to Sandra's point, I think, FWRI has a lot of data that I'm sure is helpful for your efforts, but there are several smaller projects that HSC has been involved in. If you're interested in those data sets and have a way that you might let this group know how to get you that information, if there's a format you prefer or a place to upload it, that would be really helpful to send around. John Brucker, who's not on with DEP Aquatic Preserves, may also be interested. Just another idea.
Yeah, so I will mention with that, because I had mentioned the data sets used and the oyster data sets, those mostly came from the CCAR data portal. So I know they were also working on, I think, trying to get as many data sets as possible, and they've probably added way more. But we're always looking for more data. That's more than more than an optimal thing to do. But I appreciate that, and yeah, with our next version, like I said, we're hoping to expand considerably and will expand considerably. So I'm glad I'm in touch and part of this group now, because it's definitely quite a few more resources for that type of data. So I definitely appreciate that.
Thanks, Tony.
Yep, no problem. Thanks everyone for listening in.
Nikki, did you have any? Okay, sorry, I just put your